Welcome back to the deep dive. Our mission here, as always, is to take these, well, dense stacks of research, these forecasts, and turn them into the ultimate shortcut for you. Today, we're tackling something big, a really aggressive and I think consequential prediction about AI, specifically the capabilities roadmap for just the next 3 years, 2026 through 2028.
That's right. And it's aggressive because it leans into this idea of exponential growth.
Exactly. We've pulled together some analysis that argues something quite provocative. It says, forget the expert panels trying to predict slowdowns. The most reliable predictor for AI progress for the last decade has just been extending the current trajectory, like drawing a straight line on the graph.
The straight line heuristic.
Yeah. And it's beaten the forecast time and again. It really forces you to grapple with how exponential growth works, you know? It feels gradual, then suddenly it's overwhelming.
It absolutely does. And that linear thinking, that bias you mentioned, it's probably our biggest blind spot. We see progress from year to year, say 2023 to 2024, and we just assume, okay, it'll continue at that pace.
Right, same step size.
Exactly. But the core argument in the sources we're looking at insists that the truly data-driven approach, maybe even the conservative one, is to trust the decade of compounding growth we've already seen. That straight line, which points to continued, really aggressive capability doubling.
Okay, so that's the foundation. What's our mission today then? What are we aiming to unpack for the listener?
Our mission is, I think, critical because these aren't just vague feelings about the future. We're going to break down 5 specific time-bound milestones. And crucially, they come with measurable technical metrics.
Okay, hard numbers.
Hard numbers. We want to show you exactly what the top AI models are projected to be able to do by 2028. And importantly, why these benchmarks matter, how they shift AI from just being, another productivity tool.
Like a better spell checker.
Precisely. From that to becoming a really fundamental driver of the economy, maybe even forcing new kinds of policy. Got it. So, 5 milestones, clear metrics, and the real-world impact. Let's dive in. Okay, section 1, the foundation. Let's unpack this predictive heuristic a bit more. Why has extending the straight line worked so well for AI when experts kept predicting it would hit a wall? What keeps defying the supposed limits data compute?
Yeah, it's a great question. It seems to be a mix of breakthroughs in how we build these models, the architecture, and also how efficiently we use the resources we have. The big fear was always data exhaustion.
Right, that we'd run out of quality text and code from the internet.
Exactly. But the straight line seems to keep going because of, well, 2 main things pushing back. First, the scaling laws just keep getting better understood and more efficient.
Meaning we get more bang for our buck when we make models bigger.
Essentially, yes. We get more predictable, measurable jumps in capability for the compute we invest. We know the recipe better now. Second, this is key, synthetic data generation is getting really, really good.
So the models start creating their own training data. Precisely. As the models improve, they become capable of generating high-quality, complex data code, technical documents, even scientific ideas that's good enough to train the next generation of models. It helps bypass that ceiling of human-generated data. It feeds the beast, so to speak.
So the engine keeps accelerating. And the rate implied by this straight line, it's staggering. The analysis points to capability doubling roughly every 7 months.
That's the figure derived from the observed trend over the last several years, yes.
Yeah.
About 7 months.
7 months. So think about that. If a model today can just about handle, designing a complex piece of software architecture in 21 months, 3 doubling periods.
It's 8 times more capable.
8 times. It's genuinely hard to wrap your head around that kind of change compressed into just 3 years.
It is. And to make that doubling more concrete, we're not just talking about processing speed. We're seeing improvements across core cognitive metrics. Things like the model's effective memory, its contextual understanding, its ability to reason. You can even say its equivalent IQ performance on certain tasks.
Right, so it's getting smarter, not just faster.
Exactly. Think about context windows. Maybe today's best models handle, 100,000 tokens? That's like a large book. If you keep doubling that capacity every 7 months,
the amount of information it can hold and process simultaneously just explodes.
it explodes.
Yeah.
You go from remembering the last hour of a conversation to remembering every detail of a complex multi-month project involving multiple people and changing requirements. That growth in effective memory is crucial.
And that 7-month doubling, it fuels that jump in what you called IQ equivalence, the ability to not just recall facts, but apply knowledge, solve novel problems.
Yes, the ability to pass increasingly difficult standardized tests, sure, but more importantly, to synthesize information across different domains and apply it effectively. That rapid gain is what underpins the really dramatic 2028 prediction.
Which brings us to that endpoint. The analysis argues that by 2028, AI isn't just another tool anymore. It's not just helping us work faster.
No, the argument is it crosses a threshold.
Okay, so here's the big picture context. The headline prediction for 2028. AI is expected to supply the majority of cognitive labor for any task that can primarily be done and evaluated on a screen.
Majority. That's the key word.
Not just assisting, but doing the bulk of the work. The thinking, the drafting, the analyzing, the coding for most knowledge work jobs.
For tasks evaluable on a screen, yes. That's the prediction derived from extending that capability curve. If it provides the dominant economic value of the output, it's supplying the majority of the cognitive labor.
Wow, okay. That transformation from assistant to primary labor supplier, that's the narrative thread for the next 3 years then.
That's the core story. If you buy the 7-month doubling rate, then the gains we saw in, say, 2024, maybe writing emails slightly faster or summarizing documents, they scale up relentlessly. They scale into full autonomous project execution by 2028.
And understanding that shift is key to understanding the specific milestones.
Absolutely. Starting with 2026 when AI arguably becomes, well, autonomous.
Okay, let's get into section 2, the 2026 milestones. You're saying AI goes from tool to autonomous employee. If that exponential curve holds, mid-2026 is the first major checkpoint. The analysis calls it the full shift.
That's the term used, yeah, the full shift. It signifies the moment AI, or the best frontier models, can take a complex task and run with it end-to-end without constant human handholding.
Moving from co-pilot to, well, the pilot in some ways.
Kinda. Or maybe an autonomous employee you delegate a whole project to. The capability metric they use is very specific, very concrete.
What is it?
It's the ability of the best models to complete roughly an 8-hour real-world knowledge work task, completely end-to-end. So you give it a prompt, a goal, and it delivers the finished product. Could be code, a marketing plan, a financial analysis, a design package.
An 8-hour task, a full workday's worth of complexity.
Right. And here's the critical part, the accuracy threshold. It has to do this with a success rate of greater than or equal to 50%.
Okay, hold on. 50%. That sounds not great. Like flipping a coin. Why is that the revolutionary threshold, not, say, 90 or 95%?
It sounds low, but think about the human ROI. If you delegate an 8-hour task, maybe spend an hour or two setting it up, and the AI fails 51% of the time.
You're spending all your time fixing it, restarting it. It's actually costing you time.
Exactly. It's a net loss.
Yeah.
But once it crosses that 50% success threshold, even just barely, the economics flip. If it succeeds half the time or a bit more, a single human can now realistically supervise multiple AI instances working on these complex tasks.
I see. So one supervisor, maybe 3 or 4 AI agents working.
Precisely. Suddenly, the human time investment pays off. The human role shifts fundamentally.
Yeah.
You're no longer primarily the doer. You become the orchestrator, the auditor, the one who sets the context and verifies the final output.
You're managing the AI workforce, not doing the work itself.
You've got it. You're paid for oversight and quality control, not execution. That 50% mark is where autonomous delegation becomes economically viable at scale.
Okay, can you paint a picture? What does this look like in practice in mid-2026? Give me a concrete example.
Sure. Imagine you're a marketing manager. You give the AI a single complex prompt, something like, analyze our Q2 sales data for the European market, pinpoint the top 2 underperforming product lines, develop a detailed marketing campaign proposal for Q4 to boost those lines, including draft social media posts, target audience segments, and a preliminary budget forecast based on historical ROI.
That's a lot. That's days of work for a junior team member right now.
Right. And the AI takes that prompt, works autonomously for maybe a day, maybe more, and delivers the full package. And crucially, it navigates bumps along the way.
Okay, it navigates bumps. You mentioned self-correction earlier. What does that actually involve for this 50% capable agent? How does it not just get stuck?
It means the model has built-in loops for self-evaluation and iteration within the task. This relies heavily on its improved memory and contextual understanding. It remembers the goal and the constraints. So if it drafts code as part of the task and that code fails its own internal get-it tests,
it doesn't just stop and report failure.
No. It recognizes the failure, analyzes the error messages, maybe tries a different approach, and retests. It debugs itself. Or if it generates that budget proposal you asked for. But the number exceeds the department's usual spending limits, which it knows from its context.
It flags it.
It does better than flag it. It recognizes the violation, goes back, adjusts the campaign tactics or the spending allocation to fit the constraints, and then presents the revised compliant budget. This continual learning and iteration capability is what lets it sustain that 8 hours of complex work without needing a human to intervene every 30 minutes.
Okay, that makes the 50% threshold much more significant. It's not just success-fail, it's success with internal troubleshooting.
Exactly. And the market impact of hitting this milestone 1, this full shift. The analysis says it's immediate, especially for companies already comfortable with digital tools.
So not just small efficiency gains.
No, we're talking about replacing entire slices of workflows. Think about a typical software development sprint. Maybe you replace 3 junior developers' coding time with 1 senior dev supervising several AI agents generating and testing code.
Or a marketing team launching a campaign.
Same idea. Drafting copy, generating visuals, analyzing target segments, large chunks of that get handed off, legal departments drafting standard contracts, design firms doing initial iterations. The potential for substitution becomes very real very fast.
Okay, that's mid-2026, but the curve keeps going up. What's the next milestone?
Just a few months later, still within 2026, we hit milestone 2, human expert parity, late 2026.
Parity, meaning the AI's output quality matches who?
Matches top human professionals. And this isn't just a guess. The prediction is specifically grounded in extrapolating performance on robust economic metrics. The source material particularly mentions OpenAI's GDP metric.
GDP-val, can you break that down? How does it measure expert parity?
Sure, GDP-val isn't just another academic benchmark. It's an empirical framework designed to test AI models on tasks representative of real-world jobs across dozens of occupations. 44 occupational baskets, I believe. It tries to estimate the actual economic value, the dollar contribution, a model could make performing tasks within those jobs.
So it's measuring real-world usefulness, not just like chess-playing ability.
Exactly. It's about economic value creation. And the parity benchmark predicted for late 2026 is this. At least one frontier model is expected to match the median quality output of a human with 14 years of experience in that industry.
14 years. So not just competent, but seasoned veteran level, median quality.
Median quality of a 14-year veteran across most of the tested domains. Think about that. It implies achieving the consistency, the nuance, the applied skill of someone who spent nearly a decade and a half honing their craft.
How is that even possible? Is it just the massive data?
It's the data, yes, but it's also the model's ability to synthesize that data, to connect information across vast domains in ways humans can't easily do.
Yeah.
It's the memory capacity we talked about, combined with increasingly sophisticated reasoning and, crucially, high accuracy in applying that knowledge.
Okay, so a model barely 3 years old performing like someone with a 14-year career. How do companies even begin to integrate that? It breaks the usual team structures, right?
It completely upends them. The whole model of building teams around individual human expertise starts to dissolve when you can essentially instantiate expert-level capability on demand. The prediction is a rapid shift towards what the analysis calls AI-first teams.
AI-first teams, what does that look like?
Instead of, say, a team with a senior lead, a couple of mid-level specialists, and some junior staff, you might have one highly skilled senior human acting as an orchestrator or strategist.
Okay.
And they are supervising maybe 3, 4, 5 instances of these expert-level AI models. Each model performs the tasks previously done by human experts, potentially faster and more consistently.
So the human's role changes entirely.
Fundamentally, the human isn't doing the high-value expert work anymore. They're providing the strategic direction, the high-level context the AI needs to start. They're ensuring the quality of the output, the final QA. And they're handling the deployment, the integration of the AI's work into the broader business.
So the competitive battleground shifts.
Completely. By 2027, the advantage isn't necessarily having the most raw human talent, because expert-level AI talent becomes scalable and relatively cheap. The real advantage shifts to the organization that is best at orchestrating these AI systems, who can prompt them most effectively, who provides the richest context, who builds the best auditing and validation pipelines.
That's a crucial takeaway for listeners then. The skills needed in, say, 2027 are less about executing specific knowledge tasks.
And much more about managing intelligence, setting goals for it, refining its inputs, and rigorously evaluating its outputs, especially when that output is at a level few humans can match for speed and accuracy.
Right. It's a management skill, but you're managing something far more capable than a traditional employee.
Exactly.
Okay, that takes us through 2026. Parity achieved, autonomous work is viable, but the exponential curve doesn't stop there. Let's move into Section 3, the 2027-2028 apex. What happens next?
Well, if 2026 was about reaching parity with the median expert, 2027 is when the models, following that relentless doubling curve, start significantly exceeding typical human performance. This is milestone 3, routine superhuman performance.
Superhuman. Okay, that sounds dramatic. How is that defined?
It's a natural consequence of the math, really. Once you hit the median, say the 50th percentile, the next few doublings push you up the performance curve much faster in percentile terms. The metric for 2027 is seeing top models move beyond that median parity to consistently exceed the 90th percentile human performer on many standard measurable tasks.
So better than 9 out of 10 human experts.
In specific, well-defined domains, yes. They become demonstrably superior to almost every human practitioner in terms of accuracy, speed, and consistency on those tasks.
What drives that leap? Is it just more data, bigger models again?
It's partly that, but it's also significant improvements in areas like continual learning. The models get better at incorporating new information and feedback without needing complete retraining. And they can process and synthesize vastly larger data sets than any human team ever could. Imagine trying to read every medical paper published globally last year. A model can do that.
And that allows them to spot patterns or connections humans miss?
Precisely. That synthesis ability, combined with near-perfect memory recall and relentless consistency, leads to that 90th percentile performance. It's not just about passing tests, it's about achieving higher accuracy and reliability in real-world applications.
Okay, let's talk specifics. The analysis mentions the rise of narrow AI specialists outperforming the best human consultants. In what kinds of fields are we likely to see this first?
Think about areas defined by immense complexity, huge volumes of rapidly changing data, and stringent rules. The analysis suggests examples like regulatory filings for large multinational corporations, maybe in pharmaceuticals or finance.
Way there.
Because a human expert, even a top one, struggles to track every regulation change, every legal precedent, every filing nuance across dozens of countries simultaneously. An AI specialist trained on all that data, updated constantly, can achieve an accuracy and speed in drafting or auditing those filings that's simply beyond human capacity. It might find subtle compliance risks or optimization opportunities hidden in the sheer complexity.
Makes sense. What other examples?
Highly technical fields, advanced semiconductor design, for instance. A human engineer can only juggle so many variables when optimizing a chip layout at the nanometer scale. And AI can explore billions of possibilities, potentially finding breakthroughs in power efficiency or performance that human intuition would likely miss.
Like finding a needle in a galaxy-sized haystack.
Kind of, yeah. Similar arguments apply to things like discovering new drug candidates, searching vast chemical spaces, or developing complex quantitative trading algorithms. Anywhere the data volume and complexity overwhelm human cognition, specialized AI is predicted to hit superhuman levels first.
And this level of performance, this 90th percentile capability, it enables a new business model.
Absolutely. It leads directly to what the analysis calls the rise of AI-only products and services.
Meaning no human in the loop at all?
Potentially, yes. If you have an AI agent that is objectively faster, cheaper, and performs at the 90th percentile or better for a specific task, adding a human into that loop might actually introduce errors, delays, and costs without adding significant value.
So businesses might start offering services, maybe generating legal documents, creating financial models, producing marketing analytics delivered entirely by AI.
That's the idea. And these AI-only offerings could start to outcompete traditional human-led services on both price and quality simultaneously.
That sounds incredibly disruptive. If you're a consultancy or a firm whose main asset is human expertise and suddenly an AI can do it better and cheaper,
your business model becomes very fragile very quickly. It's not just disruption in the sense of, slightly better tool. It starts to look more like potential demolition for established human capital-intensive firms in those specific areas where AI achieves superhuman performance.
Wow. Okay. And all this capability accumulation, this superhuman performance rolling out in 2027, it sets the stage for the next milestone.
It does. It builds up to milestone 4, which is projected for 2028.
Yeah.
This is when the cumulative effects become so large they start showing up clearly in the macroeconomic data. The economic knock-ons become visible.
So it moves from individual company impacts to something big enough to affect national economies.
Yes. The trigger, according to the analysis, is crossing a critical threshold in labor substitution. By 2028, after roughly 3 years of that relentless 7-month doubling,
Okay.
the share of total knowledge work hours across the economy that are supplied by machines is projected to cross the double-digit percentage mark, maybe 10%, 15%, perhaps more in certain sectors.
Double digits. That's no longer just marginal. That's a significant chunk of the cognitive economy.
Exactly. We're not just talking about quiet productivity boosts anymore. We're talking about systemic labor substitution on a scale large enough to be undeniable in national statistics, like GDP or productivity figures.
Now, historically, automation led to productivity gains, but human labor shifted, right? We moved from farms to factories, factories to offices. Is this different? If AI supplies the cognitive labor, where do humans shift? This feels different.
That's precisely the point the analysis makes. The argument is that the sheer speed and scale of cognitive automation are fundamentally different from past waves. Industrial automation replaced manual labor over decades. This is potentially replacing cognitive labor across many white-collar sectors in just a few years.
Which leads to this idea of macroeconomic detachment.
Yes. The prediction is that GDP per capita, particularly in digitally intensive sectors, think software, finance, media, consulting, maybe even law, starts to decouple from historical trends linked to human labor productivity.
Meaning the economy grows, productivity skyrockets, but it's not tied to more people working or people working harder.
Correct. Productivity in those sectors could explode, driven by AI, without a corresponding increase in human employment or wages within those specific tasks. It signals a potential break from centuries of economic patterns, where growth was tightly linked to labor inputs. Value creation fundamentally changes.
And that kind of visible, measurable economic shift, it forces policymakers' hands.
That's the final piece for 2028, the policy pivot. When the economic impacts become the significant, affecting employment figures, tax revenues, productivity stats, governments are essentially forced to respond.
So ideas that might seem radical today become mainstream discussion.
Exactly.
Yeah.
Policy proposals that were maybe confined to think tanks or academic papers move into serious legislative consideration in major economies, the U.S., the EU, key Asian countries. The debate shifts from if AI will displace jobs to how we manage an economy where a significant chunk of cognitive work is done by machines.
What kind of policies are we talking about?
The analysis specifically flags things like accelerated debate around some form of robot tax or AI value tax, trying to capture revenue from machine productivity to replace lost income and payroll taxes.
Okay.
Also, intense focus on data rights and ownership. Who owns the data that trains these incredibly valuable AI systems?
Mm-hmm.
Does the value generated flow back to the data creators?
And the big one.
And, almost inevitably, a significant acceleration of pilot programs and perhaps even broader implementations of universal basic income or similar income support systems.
So UBI moves from fringe idea to potential necessity.
The argument is that when double-digit percentages of cognitive labor are automated, the pressure to find ways to support displaced populations and stabilize demand becomes immense. These policy ideas shift from being purely ideological to being seen as potential pragmatic responses to a massive economic transformation happening in real time by 2028.
Okay, this 3-year timeline is intense. From 50% task completion to potentially rewriting economic policy. Which brings us to Section 4. What should we be watching? How does the listener track if this incredibly fast timeline is actually playing out? What are the key indicators?
Right, because it is aggressive. We need objective measures. The analysis points to 2 core high-fidelity metrics that need constant monitoring. First, something called the MeTR score, specifically tracking hours of autonomous work.
METR, what's that stand for?
It stands for Measuring Extended Task Reliability. It's basically a complex metric that tries to quantify how long, how reliably, and on how complex a task a model can operate without any human intervention. It captures the model's endurance, its self-correction ability, its effective working memory over long periods.
Like an AI stamina test?
Kind of, yeah. And for this 2028 prediction to hold water, that METR curve, plotting these autonomous work hours, has to maintain its steep, straight-line exponential trajectory.
And if it flattens out?
If we see the best models plateauing in their ability to handle, say, 8-hour or multi-day complex tasks autonomously, that would be the earliest, strongest signal that the projected timeline is slowing down. It would be the canary in the coal mine.
Okay, so track METR for autonomous capability. What's the second key indicator?
The second focuses more directly on the economic value, the output quality across different fields. That's where metrics like the GDP-Val score we discussed earlier come in.
Right, the one measuring value across 44 occupations.
Exactly. We need to watch that. Or similar multi-sector evaluations that measure accuracy, complexity handling, and success rates on real-world tasks very closely, probably on a quarterly basis.
And what are we looking for there?
We're looking for continued smooth ascent. If the models are truly doubling in capability every 7 months, those cross-industry performance scores should keep climbing steeply. If GDP-Val starts to plateau, if the models stop getting significantly better at tasks across finance, writing, coding, analysis, etc., that's another major red flag. It suggests a bottleneck has been hit, maybe in data quality, algorithmic progress, or something else, potentially invalidating that core extend the straight line assumption.
Got it. So, METR for autonomy, GDP-Val for cross-domain quality. But progress isn't just about algorithms, right? It depends on the physical hardware. Let's talk about the constraints, the accelerators, and the brakes. Hardware and supply chains first.
Absolutely critical. Hardware is probably the most immediate, tangible bottleneck. These powerful models, especially the 2027 superhuman specialists and the 2028 widespread deployments, need absolutely vast amounts of computational power, not just for training them initially, but for running them day to day, what we call inference.
So it's about having enough chips to actually use the AI, not just build it.
Precisely. And the constraint there is the supply of top-end GPUs, like the current NVIDIA H100s or whatever successors come next. If those remain severely supply constrained, if companies simply can't buy enough chips to run millions of instances of these advanced models,
The timeline slips.
the timeline for commercial deployment and widespread economic impact could definitely stretch, maybe by 6 months, maybe 12 months. The AI might exist in the lab, but if businesses can't deploy it at scale, the 2028 macroeconomic shift gets pushed back.
Okay, so GPU supply is a potential break. What about an accelerator? What could speed things up on the hardware front?
A major breakthrough in semiconductor manufacturing would be huge. Two specific areas are often mentioned: wafer scale integration and improvements in cutting-edge manufacturing yields, like for 3-nanometer chips.
Can you simplify those?
Sure. 3-nanometer yield is basically about how many usable non-defective chips you can get from each expensive silicon wafer. Better yields mean lower costs and higher supply of the most advanced chips.
Okay. And wafer scale.
Wafer scale integration is about building massive processors on a single large piece of silicon, instead of connecting lots of smaller chips together. It can dramatically improve speed and power efficiency by reducing the communication bottlenecks between chips.
So if we crack either of those problems,
If there's a significant breakthrough in either chip yields or wafer scale manufacturing, the cost of compute could plummet, and the sheer amount of available processing power could surge. That would ease the bottleneck we just talked about and could actively pull the whole commercial deployment timeline forward, maybe by 6 months or even more.
makes sense. Hardware is one lever. What about the human factor regulation? Can policy act as a brake?
Oh, absolutely. Regulatory brakes are a major uncertainty. This is where society and political systems react to the pace of change.
How might that play out?
Well, if governments, maybe in the EU or the US, become sufficiently concerned about the speed of progress, perhaps due to fears of misuse, uncontrollable capabilities, or just the sheer scale of economic disruption we've been discussing,
They might step in.
they might mandate capability pauses. Perhaps they'd say models trained using more than a certain very large amount of compute need special oversight, rigorous safety testing, maybe even explicit approval before commercial deployment.
Like regulating a powerful new drug or technology.
Exactly. And if that happens, even if the AI models achieve the predicted capabilities and the labs on schedule, say, superhuman performance, by 2027, their widespread commercial use could lag significantly.
How much lag?
The analysis suggests it could create a gap of 1 to 2 years between lab capability and real-world economic impact. The science might hit the 2028 benchmarks, but regulatory hurdles could mean the economic detachment and the policy pivot don't fully materialize until 2029 or 2030.
So it's crucial to distinguish between lab progress and commercial rollout.
Very crucial. Regulation is perhaps the biggest known unknown that could slow down the impact timeline, even if the underlying technological curve keeps going up. The 7-month doubling might continue in research, but deployment could hit a wall waiting for government green lights.
Okay, that gives us a lot to watch. Core metrics, hardware supply, and the regulatory environment. Let's try to wrap this up and synthesize. So let's just recap the sheer velocity here. We've mapped out a potential journey based on extending current trends that takes us from mid-2026, where AI can barely manage an 8-hour task successfully half the time.
Right, that 50% threshold.
To just a year later, 2027, where specialized AIs are outperforming 90% of human experts in complex fields.
A massive jump in quality and reliability.
And then by 2028, these capabilities are widespread enough to supply a double-digit share of cognitive labor and start visibly altering macroeconomic trends, forcing policy changes.
So the fundamental reshaping.
Reshaping of AI's role from a tool to maybe the primary supplier of knowledge work, all compressed into roughly 36 months.
That compression is the key takeaway. The central implication of hitting these metrics so quickly, the leap in success rates, achieving veteran-level parity, then quickly surpassing it to superhuman accuracy, is that our strategies, our career planning, need to adapt now.
Because the ground is shifting under our feet very, very quickly.
Exactly. By late 2026, based on this projection, the economic value proposition starts shifting dramatically. It's less about doing the expert task yourself, and more about effectively managing the AI systems that can do it at scale. It's about setting their goals, giving them the right context.
The orchestration piece you mentioned.
Precisely. The analysis strongly suggests that human value is migrating away from execution and towards orchestration, strategic context setting, and rigorous auditing. Your ability to clearly define a complex goal, provide the necessary background information, and then critically evaluate the output of an AI operating at, say, a 14-year veteran level or even higher. That becomes the premium skill.
Which brings us to our final thought, the question we want to leave you, the listener, with. As you process this potential exponential roadmap, if competitive advantage really does shift so completely towards those who can effectively orchestrate, prompt context, and audit these increasingly powerful AI systems.
Systems that might soon outperform most human experts.
Then what specific new skills do you need to prioritize building starting today? Are you actively learning how to manage, guide, and validate machine intelligence that operates at this projected 2027-2028 level? Or are you still primarily focused on honing the execution skills that these very systems might soon automate?
Because, according to this analysis, how you answer that question could determine how well you navigate the exponential age ahead.
A powerful thought to end on. Thanks for diving deep with us today.
Thank you.
We'll see you next time on The Deep Dive.